Algebra students, and welcome to your first e-learning lesson. This lesson is going to be a review of some pre-algebra skills that are assumed you know in this class, but it's always good to review. Specifically how you solve equations and proportions, and then some like pre-algebra skills like combining like terms and distributing. We normally start off each lesson with a learning objective. This is just like a quick one-sentence statement about what you're going to be looking at in this lesson. So for this lesson, we're talking about how to solve multi-step equations and proportions. So if I was a student looking at this, I would be wondering like, okay, what do I remember about solving equations? Do I know what this word here is? Start asking yourself some of those questions and thinking back to what you already know. So as you go through these lessons, if you're sitting there wondering like, what is a proportion? You can be on a lookout for the answers to your questions as we go through the lesson. To start off this lesson, we're going to be looking at this first equation here and talking about how to solve the equation. Now I do want to say before we get into solving equations that there's a lot of different ways you can show your work. There is sometimes a lot of different ways you can solve the equation and orders you can do the steps to solve the equation. I think for this one I'm going to show two different ways just to give you like a variety. But please know that if your work looks a little different than mine, or if you've done something in a different order, it doesn't necessarily mean it's wrong. It could just be a different way to do it. It's one of the reasons why math is so great. So looking at this equation here, what some students like to do is start off by drawing a line at their equal sign, just so you can really focus on what is on both sides of these equations. Looking here, one of the first things I notice is I see we've got a variable. That's the letter in math. We've got the variable x, and it's on both sides of our equation. When you talk about solving an equation, the answer is something like this. It's saying x equals a number. That's what it means to solve. So what we're trying to do is get our variable on one side and then be left with a number on the other side. The reason I say that is if you're ever looking at an equation with variables on both sides, at some point, something you need to do is get the variable to one side. Another thing I'm noticing with this equation is over here, I see the variable twice. Something else you could start off by doing is simplifying this. When you say simplify, it just means like making it nicer, making it easier looking. And one way you can simplify is by combining these. I could say 5x plus 3x. Well, that's the same thing as 8x. I'm going to go ahead and do that and then just copy everything else down. Copy the -9, copy the equal sign, and copy the 4x minus 1. After I've done that, I am going to go ahead and say, well, we've got x's on both sides. Let me change that. Let me bring x to one side. Now you could bring all your x's over here. That would mean we want to get rid of 8x. You could also bring all your x's here. That would mean get rid of 4x. Doesn't matter which way you do it. I'm going to go ahead and say, let me bring x to this side. And if I want to do that, that means I need to get rid of 8x. The opposite of a positive 8x is a minus 8x. The reason we are subtracting is because 8x minus 8x is 0, is nothing, and the word you hear a lot in math is those cancel out. Now, whatever you do on one side, you do on the other, which is why this line sometimes helps students. So if I write minus 8x on this side, I'm also going to write it on this side, and I'm going to write it below the 4x because those are like terms. I can subtract those. I couldn't subtract 8x from a number, so that's why I put it here. After I do that, I want to see what I'm left with. On this side, I've got 4x minus 8x, which is going to give me a negative 4x. Negative because I'm subtracting a larger number. I've still got that minus 1 there. And then on our other side, these have canceled out, so I'm left with a negative 9. Once I do that, this is what we call a two-step equation. If I want to get that variable x all by itself, there are two numbers left that I need to get rid of. Do you have an idea which one you would want to get rid of next? We usually start off with what we call the constant, which is the number without the variable. It's the number that is added or subtracted. So in this case, it's the minus 1. We get rid of the minus 1 by doing the inverse operation, or the opposite. The opposite of minus 1 is plus 1. And just like before, I'm going to do that on both sides. When I do that, negative 1 plus 1 leaves me with 0. It's nothing, so those cancel out. And I'm left with a negative 4x on this side. And then on the other side, a negative 9 plus 1 leaves me with negative 8. There's only one last step to do, and that is to get x all by itself and eliminate the negative 4x. When you've got a number next to a variable like that, it means multiplication. This means negative 4 times x. So the opposite of multiplication is division. So I could come in and say, I want to finish by dividing both sides, and I want to divide by the number I'm trying to get rid of. I want to divide by negative 4 and negative 4. When I do that, negative 4 divided by negative 4 leaves me with 1, not 0. Sometimes students want to say 0. Gives me 1x. Well, there's my 1x, which we just write as x. And then on the other side, negative 8 divided by negative 4 leaves me with 2. We get our final answer, x equals 2. I want to pause here to address some things. Some students are going to be sitting here like, I remember this, I love solving equations. You might also be looking at this saying like, whoa, there's a lot of steps in this problem. I said at the beginning that this is like a quick lesson to review some pre-algebra stuff like solving equations, but there's a lot of stuff I've done in this problem that sometimes trips up students who haven't taken pre-algebra with us. One is this thing I did here at the beginning with combining like terms. Also all these steps, the subtracting 8x, the adding 1, the dividing, and then there's all those negative numbers too. The negative 9 plus 1. Where did negative 8 come from? You might not know. If at any point here I was doing something where you were like, whoa, you lost me, this is a perfect time to advertise. We have tutoring. Please reach out to us and we would be happy to give you more extra practice on this. We've got one day planned to kind of review through a lot of stuff, but that doesn't mean that one day it might not be enough time for you to review all this. So just reach out and we can make sure we support you if you need some extra support. Coming back to this problem, there's a couple things I wanted to talk about. We said x equals 2. When you say x equals 2, yeah, that's the answer. But what does x equal to, what does that mean? Take a moment and try to figure out what that means for this problem. When we say x equals 2, what it means in this equation is that if you put 2 here, and here, and here, it would make those two sides equal. When you talk about solving equations, there's only one magical number that's going to make this side of the equation equal to this side. And for this equation, that magical number is 2. One of the things I love talking about in math is how you can check your answers. You could check your answer to this problem by doing exactly what we said. We said if x equals 2, that means if I put 2 here, here, and here, the sides should be equal. Well, let's check that. Let's make sure those two sides are equal if we do that. This is called substituting. When you substitute something, it just means you're replacing the variable with the number. So when I go to substitute to check my answer, I could say 4. Instead of 4x, I'm going to say 4 times 2, because remember we said this means multiplication. So 4 times 2. Where did that 2 come from? Well, it came from our answer. I'm going to keep copying. Minus 1 equals 5 times 2 plus 3 times 2, and then minus 9. Depending on how good your mental math is, you might be able to look at this and kind of do all this math in your head and figure out if the sides are equal. I am a teacher, so I will write it all down. I'm going to go ahead and say, well, 4 times 2 is 8. So that side says 8 minus 1. This side over here, 5 times 2 is 10. 3 times 2 is 6. And then we've got our minus 9. So we've got 10 plus 6 minus 9 on this side. Remember, we're checking to see, are those two sides equal? Well, this side is equal to 7. And then over here on this side, 10 plus 6 is 16. So we get 16 minus 9. Well, the left side it was 7. The right side, 16 minus 9, is 7. That is exactly what we're looking for. What we did there is we proved why x is 2. We said if I put 2 for x, it shows that the two sides are equal. If you went to do your check and you got like 7 equals 70, that's not true. What would it mean if you go to do your check and you get something like this? It means our answer wasn't right. It means we didn't find that magical number that makes these two sides equal. So if you were checking, that would help you know at home that, hey, I did something wrong. Maybe I should go back in and look at my work. Now, one last thing I wanted to say about this problem. I had mentioned at the beginning there is a lot of different ways to do this. One reason why your work at home might look different than mine is some people, instead of writing minus 8x at the bottom, just put it next to it. So instead of saying 8x minus 9 minus 8x here, they write it over here, which is great. It's just a preference. Your work also might look different if you did this problem in a different order. So just to give you an example of a different way you could do this, I'm gonna go ahead and copy the problem again. Last time I started by combining these two terms. That's not how you have to start though. Some people might look at this and say, okay, I've got x's here, I've got x's over here. Let me start by just getting rid of the x on this side so that all of my x's, all my variables are over here. So some people might start by saying, let's subtract 4x on both sides. I'm going to subtract it once on this side, and I'm going to subtract it once on this side. It's an option. We could go ahead and say, well, those cancel out, so I get -1. Over here, 5x minus 4x gives you 1x. You could write 1x, but more often than not, you're just going to see x. And then we've got plus 3x minus 9. Looking at this, our next step could be combining these together. So -1 equals 4x minus 9. Our next step, since x is on this side, these are the numbers I need to get rid of. So our next step could be, instead of -9, add 9 to both sides. That's going to leave us with 8 equals 4x. Now notice, this is looking different than what we did over here. Over here, we were adding 1 on both sides. Now I'm adding 9 on both sides. Our last step, since x is next to that 4, this means 4 times x. The opposite would be dividing by 4. That's also different than what we did over here, because before we were dividing by -4, because it said -4x. But look at the final answer. Over here we get x equals 8 divided by 4, which is 2, which is the exact same thing we got over here. So what I was saying before is really true. There is a lot of different ways you can solve this equation. Oh no. But all of those ways will give you the same answer. Just a minute, technical difficulties. Okay. I'm gonna take that as my cue. We talked about this problem too long, so we'll go ahead and move on to the next one. The next one is one that I want you to try on your own first. Looking at this, it looks a little crazy because there's decimals, but the steps are the exact same as what we just did. So go ahead and try this one now. All right, well, what did you do? One option you could do to start is, I noticed we've got c's on both sides, so we need to get rid of one. If I went to get rid of 4.3c on this side, that's going to leave me with nothing over there. You could write a 0, or your other option is, let's get rid of this one. If I get rid of 8.3c, that's going to leave me a number on this side and a c on this side, which saves us an extra step. I'm going to go ahead and subtract 8.3c minus 8.3c. If I do that, I get 6 on this side, and then over here, 4.3 minus 8.3, I'm subtracting a larger number, so it'll be negative. And when you subtract those, you get 4.0, or just 4c. Last step is divide by -4, since this means multiplication. Now there's something fun happening with this problem. Over here, if you have 6 divided by 4, those don't divide evenly. One option you could do is leave it as a fraction. Another option you can do is actually get the decimal value. If you're leaving it as a fraction, you would want to simplify. You can simplify by dividing both these numbers by 2, which would leave you with -3/2. Or if you wanted to divide 6 by 4 and actually get a decimal, it would still be negative, but it would be the decimal 1.5. Either of these are good options. I personally, since the problem already has decimals, I would probably want to be consistent and keep a decimal. But they both are the same number, just written in a different way, so both are good. Now this last one over here, look at those fractions. One option for you to solve this would be pretty much doing the same thing we did over here, right? I see I've got a variable here, I've got a variable here. I only want variables on one side. And so you could start by subtracting 3/4 x on both sides. And that is a very valid way to get an answer. The alternative to doing that, though, is starting this problem off differently. One option you have, anytime you're looking at an equation with fractions like this, is you can start off the problem by doing something to actually get rid of the fractions. I want to focus in for a second on what this means. One way to read this is as a fraction. Another way to read it is as division, right? 5 divided by 4. If we think about it as division, that's going to help give you a clue as to a different way you can start this problem. If I wanted to get rid of the fraction, that means getting rid of the divided by 4, the divided by 4. So using what we've seen with these steps, you're always doing the opposite. The opposite of dividing something by 4 would be multiplying by something by 4. So what we could do to get rid of these fractions is I could multiply this side of my equation by 4. Now just like over here, this said multiply by -4, divide by -4, and those cancel out. The same thing's going to happen here. If I've got this 4 that I'm multiplying and this 4 that I'm dividing, those 4's cancel out. A different way you could see it written is something like this. Instead of putting one big parenthesis, I just separated it, but the idea is the same. Times 4 divided by 4, those 4's will cancel out, which just leaves you with your 3x. Over here, the same idea. Those 4's cancel out, and you're just left with the 5. The biggest mistake students make on these is they try multiplying the 4 and the 3 to say something like 12x. Different way you can think of this is 4/1 times 3/4. If you do that, 4 times 3 is 12, but you still have the 1 times 4 is 4 on the bottom. That leaves you with a 3. So just a different way to see why it's 3x. Now notice I multiplied this side of the equation by 4. Remember, same as all these other ones we've done. If you're doing something on one side, you've got to do it on the other side. So we would want to come in here on the other side and multiply this side by 4 as well. So after we multiply this side by 4, I've got 3x plus 5. After we multiply this other side by 4, you're going to have 16x. Now, quick summary. The reason why I'm multiplying by 4, the 4 is coming from the denominator, which is the fancy name for the number on the bottom of the fraction. And the reason we're multiplying is because we're just doing the opposite of division. These both say divide by 4, so the opposite would be multiply by 4. And then just a quick reminder, whatever you're doing on one side, you're doing on the other side. If instead I had given you the equation 3/2x plus 5/2 equals 4x, then we'd be multiplying both sides by 2. Once you do this, now it looks a lot friendlier because there's no fractions, and so we can just finish solving. There's x's on both sides, so I could bring my x's over here and say minus 3x minus 3x. If you do that, that leaves you with 5 equals, over here, 13x. And then our last step, divide by 13, and you're left with 5/13 equals x. You could write that as a decimal if you wanted to. Again, kind of being consistent like we said before, decimals in the problem, so I'm writing my answers with a decimal. Fractions in the problem, I'm going to write my answer as a fraction if it can't be divided nicely. The other thing about this fraction in particular is before, if you were to divide out this fraction, it gives you like a nice finished decimal. This one, if you were to type it into a calculator, that decimal is just going to keep going forever and ever. So it's more precise to leave it as a fraction. And that would be our final answer. So I did 3 examples. I'm going to give you the opportunity to try this next one. Go ahead and answer number 1. Go ahead and try number 2. Okay. There is a question down here at the bottom that says, look at how you solved number 2. What was your first step? Explain why you did that. I do want to talk about this last one. Just like we said before, there's a couple different ways you can do this. If you feel really confident, like adding, subtracting fractions, you don't need to do that crazy stuff I was showing you. I've just been doing this long enough where I've seen some students aren't as confident adding and subtracting fractions. So an alternative way to do this problem would be to come in and multiply both sides of your equation. What number would we want to multiply by? For this problem, we would want to multiply by 2, since that fraction has 2 as the denominator. I'm not going to do the whole thing, but I'm going to show you what it looks like after you multiply. When you multiply these 2 here, those 2's are going to cancel, which leaves you with 3x. We have to multiply the entire side. So when I multiply 2 with this term, it gives me 3x. But then the 2 times the 3 here gives me 6. On our other side, when I multiply 2 with 5/2 x, those 2's cancel and you get 5x. And then the 2 times the 1 gives you a 2. Hopefully once you've got to this line, you can finish it up. This is the first part of the video. The other part of the video is going to be on something called a proportion. Do you remember that from the objective? We said we were going to solve proportions. The definition for a proportion is an equation with 2 equal ratios. When you talk about ratios, the most common way to see them is as a fraction. So an example of a proportion could be something like this, where we've got a fraction equal to a fraction. Anytime you're talking about solving proportions, the trick a lot of students use is something called cross multiply. Cross multiply looks like this. You would want to multiply this term with what's across from it, and then it will equal this times the term across from it. Hence cross multiply. The multiplication is because these problems already have division in them. Now when you do that, it doesn't matter which way you start, but you could start by saying 9 times k. Well, that's 9k equals, we want to say k minus 5 times 3. What would that be? Well, this time, because there's 2 things here, you want to make sure you're multiplying the 3 with both of them. 3 times k is going to give you 3k, but you also need to do the 3 times that minus 5, which would give you minus 15. After that, now it's just like the problems we were doing before. We want to bring k to one side, so one way you could do that is subtracting 3k on both sides. After that, you've got your 6k equals negative 15. Your last step is dividing both sides by 6. That leaves you with k equals negative 15 over 6. I'm going to leave it as a fraction, but I can simplify that fraction. Do you see what number you can divide 15 and 6 by? 3. If you do that, 15 divided by 3, or I should say negative 15 divided by 3 is negative 5. And then 6 divided by 3 leaves you with 2. So we get this for our final answer. Now there's one last one here that I'm going to start, and I'll have you finish it. This last one here is similar to this one over here, but not quite. Do you see what's different about it? I think the biggest difference between this problem and this one is over here, this was a true proportion. We had a fraction equal to a fraction, But over here, it's not, because we have a fraction here, but this isn't a fraction. One way you can do this is like we did before. To get rid of that fraction, you could just come in and multiply both sides by 2. Over here, those 2's would cancel out, and then you would have a nice equation with no fractions. Another way you could do this is to make this look like a proportion, we need a fraction equal to a fraction. I've got a fraction on this side, but this side isn't a fraction. Do you know how to turn a number into a fraction? Well, you can turn anything into a fraction by putting it over 1. Some students really like to solve equations by cross multiply, and if you do this, then you can solve this the exact same way you did over here. You can cross multiply by saying 3x plus 5 times 1 equals 2 times 16. I'm going to have you go ahead and finish this one. Did you get it right? Well, 3x plus 5 times 1 is just 3x plus 5. 2 times 16 is 32. You would subtract 5 on both sides, which leaves you with 3x equals 27. And then that last step, divide by 3, leaves you with your answer, x equals 9. That's my last example. I have 2 last problems for you to try. I will clean the board so you can see them. This first one here is just a proportion similar to what we were already doing to solve. This one over here is a little different. This one here, the directions say what mistake did the student make, help the student correct their answer, and make sure they understand why their mistake is wrong. Go ahead and try this first one. Now go ahead and try this second one. You're going to look at the work that the student has provided you, and then you're going to figure out what mistake did the student make. They're saying the answer is z equals -4/3, but that's not right. So somewhere in their work they did something wrong. All right, I do want to talk about this one just because these written responses sometimes students have trouble with. You want to be the kindest teacher in the world. You want to look at their work and not just say, nope, that's wrong. You want to be specific when you're saying what's wrong with their work and helpful. You want to make sure they understand why it's wrong and don't just say, no, that's wrong. After looking through their work, you might have noticed that when they went from this step to this step, they've got a 12z there. And you might have noticed that and been like, where did that 12z come from? If you figure it out, that 12z came from them adding these two together. The problem with that is if you have 8z equals 4z minus 16, you don't want to add these. If you're trying to get z over to this left side, you would want to subtract 4z on both sides. That would leave you with 4z equals -16, and then you could finish solving. So as their super kind friends helping them identify their mistake, you could say the mistake was when the student wrote 12z. They got 12z by adding 8z and 4z, but you don't want to add, you want to subtract. We're using subtraction because 4z minus 4z leaves you with 0, which is nothing, and we don't want any more z's on that side. Notice if you had added 4z on both sides, that's not helping you out, is it? It's giving you 12z over here, and it's giving you 8z over here. So something along those lines. It doesn't need to be quite as long as I did. I'm the math teacher, so of course I'm gonna embellish the answer. But make sure you explain why you would want to be subtracting and not adding those two together. Hopefully you found this first video helpful. I am so excited to see all your faces on those 10-minute Google Meets, and I will see you tomorrow for a new lesson. Thanks, bye.